we're going to be talking about proving triangles congruent with side, 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 or side angle side. Before we get started with that, I want to show you on the back of your notes, there are theorems that are helpful for the middle part of your proof. Yes, you have that theorems packet. However, these are the most common things that you're going to use in a proof. I'm not saying that there aren't additional things that you might have in your theorems packet, but these are the most common ones. And when we get to talking about this, you'll be looking at the given information and trying to figure out, okay, if I see the word midpoint in the given, then I know I'm going to have to use the reason of definition of midpoint somewhere in the middle of that proof. So just kind of giving you a heads up there that there is a sheet at the end that will help you with your proof writing. So let's go ahead and get started on this otherwise. So the first method that you're going to use in order to prove two triangles congruent is the side, side, side congruence. We are looking at two triangles in which we are proving all three sides are congruent, or that's given to us already somehow. The other method that we're going to use is side angle side congruence. With this one, the angle has to be in the middle of your two congruent sides, because we don't spell naughty words in math. So again, the angle has to be in the middle of those two congruent sides. So just looking at example one, determining whether the picture shows side, 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 side angle side, or neither. So looking at this first one, I can see here the angle is in the middle of my two congruent sides. Check. But over on the second triangle, my angle is not between my two congruent sides. So this is a neither. On B, you have to think outside the box here. These two triangles share a side. So if this is a side in triangle 1 and triangle 2, because they're shared, we know automatically that that is going to be congruent to itself. So this is side, side, side. Now looking at triangle C, once again, I have a common side that is shared. Looking at triangle 1, my angle is not between my two sides. So this happens to be a neither. All right, so on this proof, generally speaking, when we're talking about a proof, the first statement, we already know this because we've talked about this before, is our given. Generally speaking, I will give you a line for each given. In this situation, I forgot to, so I'm sorry. So all of your given information is supposed to fit in one box. I'm going to just extend this, and we will have BC is congruent to EC, and then in line 2, we'll have AC is congruent to DC. And those are both given. We also know that the prove goes in the bottom statement. So triangle ABC is congruent to triangle DEC. So we already know that. So now looking at this, we're going to have to use our proof help at the very end. So looking at this, going back, I'm sorry, kind of Blair Witch Project scrolling here. In our given information, did we have anything that talked about a midpoint? No. We had nothing that said bisects, so skip over the first next two. We had nothing that said perpendicular, no parallel lines, but we did have a bow tie picture. So we're going to have to use the vertical angles theorem. So looking at this, we already know vertical angle theorem. Well, my vertical angles are here and here. Now remember, we just got done doing this, talking about the lettering. The lettering does matter for your angles here. So we're going to have angle ACB is congruent to angle DCE. Now looking at my picture, I can see that my angle that's congruent is in between my two congruent sides. So my two triangles are congruent due to side angle side. Example 3, same setup. I'm sorry, there should be a fourth box again, but we'll just do it all in one since I don't have room to keep going there. So we have HE is congruent to FG, and we have HG is congruent to FE, and this is given. So again, going through that proof help sheet, you can see that we have an overlapping side because both triangles 1 and 2 share side GE. So that's my third congruent side, which means I'm going to have reflexive. This is the easiest property to have. It's the easiest one to spot, I should say. So when we're going through, again, the lettering matters. So if I look at my proof information here, E corresponds to G, and G corresponds to E. So I have EG is congruent to GE. We already know my proof, and I can see that this is side, side, side. So you will have a worksheet that will deal with these proofs, and it is just for you to get more practice with it. I know this is the first time that we're dealing with the triangle congruence proofs, so it can get a little tricky. But if you have questions, please ask me when we are in person.